Armaan, I am so excited to be back to visit with you again after your science fair project that I had a chance to hear about on a recent Saturday, and what better way to spend a Saturday than doing science. But Armaan, I just was so impressed with your theory, right, your hypothesis, and just want to ask you to explain for a minute what you were trying to do and sort of what math you were using and equations.
My project's about the theory of general relativity. It's like the theory that space-time tells mass how to move and mass tells space-time how to curve. For example, large masses like, for example, the sun, bend space-time a lot, and smaller objects like planets and moons follow the curves and bends of space-time.
Right.
In this theory, there are like 4 main equations. The first one is the Einstein field equation.
Right.
It tells us how space-time curves. The second one is the geodesic equation. It tells us that objects will move in the straightest possible line through curved space-time. For example, the straightest path right now from here to here would be straight. But now, if you were to follow the same path, it would go over there. So you would need to curve it a
Right.
bit. And then the third one is gravitational time dilation. It tells us that light, in areas of intense gravity, time will slow down for light. Since light will always move at the same speed, no
right.
matter what, it takes like 1 second from here to here. But now it would take more time, like 1.2 seconds to get from here to there. So time would need to slow down for light to get at the same
Right.
speed.
And that's a constant always, that light moves
Yeah.
at the same speed. So it's so important when you're doing science to know what can change and what doesn't change, right? You really did a nice job. What's the next equation you looked at?
The energy momentum equation. It's about like how light, even though it has no mass, it's still affected by gravity because gravity is just the curvature of space-time. Like in the geodesic equation, it's just following the straightest possible line.
So what do you make of all of that, Armaan?
There's like a few gaps in this theory, like where it will connect to, how will it connect to quantum physics.
Right. So what do you think the next science steps are for the future scientists?
Connecting quantum physics, quantum relativity, and theory of relativity, theory of special relativity, all of those together. This will be important for our future to realize how the Big Bang Theory came to be, because right now there are some very large gaps, like how it appeared out of nowhere.
I think when I think about it, I think we have to stay curious a little longer, right? Like there's still some questions that aren't answered about the work that you've done here, right?
Yeah.
What are some questions still that remain for you?
How do we connect this to other theories?
Yeah, it all comes back to that wonder, doesn't it?
So in the spring of last year, we had a number of students who are young scholars who are participating in an after-school robotics program. In the winter, we had a 3rd grade teacher offer robotics to our 3rd graders, and the request was through the roof. She only had 30 seats. We had 85 people who requested to join her.
Yeah.
So it became kind of like a little...
How do we not?
Yeah, how do we not? But we realized right then and there that we had a number of students who were interested, far more interested in science and doing things in science and had their own interests. So in the spring of last year, myself and Ms. Sly, our AART, began planning for a Lorton Station Science Expo.
What a great idea. So what was the kids' response, Ms. Tynes?
They were excited, especially Armaan and a few other his peers. They were excited to do something on their own, one. They were excited not to have limitations as far as what they could do in the expo and the project-based assignment. I think they were good. They were excited. It was good.
Yeah. I love what you said about not having a ceiling.
Yes.
Because I think sometimes we limit the thinking of our young people.
Yes.
And really, education in its purest form lifts children up to think their best thoughts and be their best selves, right? So any big learnings from this, Ms. Tynes? Anything, as you know, I know you, as educators, you reflect on units and lessons taught?
My biggest thing was just allow them to explore, not necessarily focusing on standards, just allowing them to explore. I did not know at first what his thought process was, but I'm very proud of what he came up with. Just allowing them to have that curiosity and allowing them to, again, break the ceiling of what I'm expecting and what parents are expecting, I think that was the most important, and I look forward to it.
I go back to this one phrase a teacher said. She said, it opened my eyes. It opened my eyes to what our students could do because there were no limitations.
Right.
And there were so many different projects of so many different things where kids had questions about this or that. We showed you someone solved Kiss and Ride. They came up with an app just for Kiss and Ride. And but that was their big scientific question, like how do we solve the struggle of Kiss and Ride and calling and moving people?
Right.
And I think other kids had a chance to see who did not complete one this year and were like, oh, I want to do one next year.
Yeah,
so we're
exciting.
excited about it for next year.
Science is contagious, right?
It is.
And as we move forward also with more and more advanced math at earlier and earlier grades, I think that students have a choice about.
Yes.
We're going to see, I think, continue to see the lid blown off of the potential of our young people. So really excited. You guys are inspiring me. And Armaan, high five. Good job.